Right, we're back, and for today's video I'm going to take a tour through a model like we have done in the past. I'm going to see where this goes. This is a pretty large amount of work that's gone on to here, and it's a nice looking model, and we are looking at a rendering. So I'm going to touch on a lot of different areas of Onshape, some of which are very new, like indeed the Render Studio. The Render Studio has had a significant upgrade in the last couple of releases, and so I'll touch on some of those things. But before we get to that, I'm going to talk through how I did this model. And I know that if you go onto GrabCAD, you can see this very model. It's a very famous. It actually comes from kind of 90s, maybe late 80s and 90s. You can read all about them. They're fantastic motors and beautiful engineering in them, and they happen to be really good parametric modeling case studies. So I know there's a lot of them out there and of different qualities, so I decided I'd do mine from scratch. There's no imports in here. This is all done from scratch. So if we go over to the assembly, here we are. This is what we're going to end up with, and this is just a quick tour around it. And as I said, this is pretty complete. It is complete. It's got the full parts list, and it is very, very clean, which has been the whole process and intent behind the process here. But not just to create the shapes, but to look at the methods that go into making those shapes. And let's start with some of that and then see where we go. In fact, it's going to jump around a little bit because I'm going to show you some of the other new things that have happened lately. And of course, we're in Onshape here. We've got the version graph, and you can see that I've been having a few different versions. I thought I was nearly done, then I was nearly finished, and then today is demo day. Right? So I've created a branch where I'm going to clean up the modeling, and I'm going to work in this branch. And there's a reason for doing that as well, and there's something that's new, brand new today, is that for any workspace, such as main, and especially main, you would apply to this, you can right-click on it and say Workspace Protections. So if I enable Workspace Protection, what that's going to do is restrict the changes that can be made in main, or whichever workspace I choose to protect. It will restrict the changes so that I can only merge changes in that have been done from a different workspace. That is a really, really good idea, so that you always keep, and you can see the lock symbol here on main. If I go back to main, you'll see that I'm actually essentially going to be in a view-only environment. I'm not going to have any icons. I can't make any changes, and it tells me up here, changes must be merged in from another workspace. So those of you that are familiar with software development will understand that this is very similar to Git style working, where you do all your feature changes in branches, and once you've tested those, they can then only be merged into main. Right, well, we can get into that a little bit later, but for now we're going to be working in this feature branch called cleanup model, and we'll get onto that later. So that's brand fresh, new. It's only a couple of hours old, so let's have fun with that. The other thing that's in new, reasonably new, and maybe two releases, is the action items are a little bit more accessible now since they're right on the side here. And I use these action items and create tasks for myself for things like I find something that's wrong or something that I need to address. See, I haven't quite finished the carburetor stop screw. So I make a little task for myself, and I can view the task, and it's just the same as if I'd gone and I looked at tasks and action items previously. But they're very convenient because these are the tasks that are being filtered for me that are relevant to this current document. They don't show me all the tasks and comments and action items coming from other documents. These are ones specific to this current document. So I use this, including the comments that I make to myself, just sort of a to-do list. And these are the sort of modeling things that I'm not going to get to all of these now, but this is what I really have to do to finish off this model. So that's the action items that are right here next to the performance monitor. And so you can, if you're like me, you can use this as your to-do list. Right, so let's start and having a look at some of the modeling. So the major component in here, of course, is the crankcase. And the red faces you see here that I've used the appearance panel to create these additional appearances to, these refer to machine surfaces. So whether they're going to be machined with a hole making or some other milling operation, I just like to color them that way, and so it's a convenient way to do with the face appearance setting there. And you can, this isn't that complicated a model, so you can, like I've seen some of the other ones especially on GrabCAD, you can just start from the bottom up, just start modeling parametric extrudes and sweeps and revolves and things like that. But in fact, it's better to take an approach which is a lot more functional, and you're going to do something that looks a lot like this. And that is to start with the casting cores and actually building the cores parametrically first. So you'll see in my feature tree, I've actually divided into folders. The core features, the casting features, the machining, and then some other things that come a little bit later, including an interface. This interface is going to be nice because this is a surface that I'm going to share to somewhere else to do some more modeling inside a different part studio. In fact, indeed, could be in a different document. But again, we'll get to that. And let's start with the core features first. Now, the first, and I've actually modeled these as different parts even. So I'm really using some of the really nice bits of Onshape's, multi-part studio capabilities, and you'll see how that all comes together in a little bit. So the first thing, I start doing some extrudes, and these sketches, if I go into this very, very first sketch, you'll see that this FX down here in the sketch dimension refers to something, again, it's pretty new. I'm going to highlight lots of new stuff here. This is not brand new, it's a few releases old now. But it means that this dimension here is being driven by an expression. In fact, I can show that expression directly just by clicking in here in the sketch dialog. And that expression is coming from a variable. Just the hash refers to a variable name, crankcase ID. Right? So that's good. So let's go over and see which variables or what variables I've got for this model. Right, so this is not new, but it's a very powerful and probably a little bit underutilized right now as people are still getting their heads around it. That is, I'm using a variable studio to provide global variables. And these global variables kind of like the system level specifications. And in fact, I'm going to call them specifications. Things like the piston bore or the sleeve diameter, the bearings, the front and rear bearings, and deck height, and then the mount spacing. So these are things that are probably shared between a lot of different parts, and they're kind of standard. They're almost standards, especially this mount spacing, the width and the length between the mounts of the motor. These are going to be standard for across multiple different model lines. So it makes sense to keep them as global variables. And all I've done is I've created this, and let's get out of that and go back to see where these variables have come from. These variables, and you can get a telltale hint here, these not even in this document. These variables are coming from a different document, which is linked. That's what that link means. And that document is actually this one here, and it contains, well, actually it contains pretty much, there's nothing in this part studio. It only contains this variable table here. So I've got those same high-level variables, and in fact there's a few more of them in here. This is the global set of variables I want to use for the entire project. And for this particular part studio here, crankcase, what I've done is I've chosen a bunch of them, not all of them, to come in. It's like I don't need the stroke or the shaft diameter of the propeller or the piston diameter at this point. So I'm not going to use them. I don't want to overload my table here for the purposes of doing the crankcase. I do have some local variables as well. In fact, and these are ones that I might not sort of consider so important shared across different part studios, and maybe they're just ones that I'm using just to make my own modeling life easier for very local changes, and so I'm not going to put them in a variable studio that's linked. Now the important thing is that this is coming from a version, so I can version manage and in fact I can release this as well, so I can really control those global variables very tightly, and then just have them update when and if I need to into things down here. Right, so having found all these, you'll see that a bunch of these refer to other ones of those. This here is the rear bearing inside diameter. Again, I should show the expression there, and you can just show that that is indeed the rear bearing inside diameter, which is 15. Right. So for this first crankcase core, I did the main parts of it there, made the main functional parts of this crankcase. And I'm not going to go into how these two-stroke engines work, but it's very fascinating. So also, to make my life easier, I haven't bothered with fully Booleaning these things together. I don't really need to. In fact, I like to keep these separate. Let's focus on the function of the cylinder. So the cylinder is where the piston essentially is going to go up and down in here, and the conrod's going to be somewhere down here. And these lumps on the outside are where the ports are going to be. So the gas has to flow up the side and into the top of the piston, and then this is how again, I'm not going to go into how the two-stroke works. But having this as a separate body is extremely convenient. It keeps me separate from anything that's going on down in the crankcase itself, like that. And then the third one I did was the exhaust port. Now this is very important, a couple of dimensions, including the width and the height of that port, the tapering angle, and the height of this, in fact, above the centerline of the motor. So these are fundamental things that I'm getting from variables that I've shared myself into. So once I have those, and that should take me through this first folder, which is the core features. And I think at this point, I just added a couple of functional fillets here for the for that core. Then I get into, let's create the casting around it. All right. So if I have a look here, and maybe I'll just roll down a little bit, or roll up, as the case may be. So the first feature I create is going to be just building around the core. Right? You can imagine we're just building chunks of material around this core, and of course later on we're going to Boolean subtract the core from all the stuff that we create here. Again, I'm using variables or expressions that are related to these original variables, so the thing ends up being very parametric. You can see sometimes I have used local variables here to create myself a wall thickness variable, and that again is just sort of offsetting 2.5 millimeters or so from that inside core, which is the one that was this the one in here. There's the sleeve diameter of 25. Right, so we're building this, and again I like to build these in separate bodies. You can see that the cylinder casting bit is different from the crankcase casting piece. And later on, you'll see that I start to build some more geometry. This is going to be the cooling fins. All right, so again, you can do these in individual bodies. Like this is a part. If you have a look in the parts list down here, it's part 7, it's just the fin, and it's very nice. You can do things, transform them, move them around, build them parametrically, and then when you do the pattern at that point of the patterning, just have a look at this, you'll see that I've used an add modifier on that pattern, which is when I create the pattern of 6 ribs, it's actually going to add it to the scope, which is that original dark blue cylinder casting. So that ends up, now that I'm getting closer to recognizable geometry, you can see how I've built the exhaust port casting as a separate body as well. And these are all just building up on top of each other. And let's build down to here. You'll see I've built the mounts. And the good thing is I don't have to worry about merging two faces or extruding two faces and trimming off or anything like that. In fact, I've just blown straight through it. With this engine mounting, you'll see that the engine mount geometry was a very simple one that I just built the length and the width of it, built a big slab for it and put some fillets on the corner, and that is a separate body which I can just keep in existence until this next step, which is to do all of the merging of the cast parts. So these are the parts that the exhaust port, the cylinder, the crankcase, and the mount. So if I look at that feature now, you'll see now that I've created a single, if I cut through it in a section, you see this is a big solid lump. All right, and then it's not really that much magic now. I've kept in a different folder a bunch of ribs. Now there's some reinforcing ribs that go down the side, underneath, up here. They're the ones that are going to look a lot like this, and there's a couple down the side as well. Oops, let's turn that section off. You can see where those ribs are. I like to keep them in their own little folder because, in fact, at this point back before we did that, the ribs, it might be a good idea to start doing some, some sort of other evaluation, before we get too detailed. All right, so we can roll back to here, and then there's some logos. So the logos I have kept pretty simple. I'm going to roll them. This is a 0.46 cubic inch engine, or 7.5 cc, for those of you in other parts of the world. All right, so then the next section for the casting was just a whole bunch of fillets. Like this is all going to, there's a lot of fillets that need to be applied in here to make this a nice clean model. So you can see I've kept them in a group as well. So they're conveniently kept together so that I can suppress or unsuppress as I need it. So there's a lot of nice filleting in here. It's a very clean model in the end. Yeah, pretty happy with that so far. And now we're down to one cast body and these three cores, which I can then just extract or subtract, from there. I keep the cores around. You can have the option to keep bodies, and that's what I always use, so that I can bring them back later for viewing. Yeah, for viewing pleasure. Anyway, that is more or less the cast part, and then there's a whole bunch of machining features, like all the holes and some cutouts that need to be placed in here. So I put them in their own folder as well, and you can see, let's start rolling through that. There's a couple of holes in here which are tapped. These are clearance holes. You can see those ones lighting up there. We just keep a look on the whole table as well, what's going on. Holes features have had a lot of improvements in the last few releases as well. So, I've been exercising some of that in here as well. So this is the mounting holes here. And these are the rear tapped holes. I think they're at M3. That's right. You can see the ones in the crankcase are these 4 tapped holes, right, with a blind depth. Right, moving through, there's a bunch more holes. There's some extrudes. There's this was a machine cut that you could see that would be a machining operation that happens after the casting, as well as the facing that goes on up the top here, and that's why it's in red. Anyway, I will just fast forward to the end of this, to here. That takes care of the crankcase. Then there's some sort of ancillary or extra features, and this one is the gasket that goes on the back. So that's a simple thicken. Of course, it's going to be parametric. And then there are some additional features that are going to build. In fact, I built this in a slightly lazy way for the rear cover, which is the cover plate body. I could have done the same methodology as before and kept the machining features away from the casting features, but in fact I just wanted to mainly demonstrate that bit with the main crankcase. The last feature in here is a surface offset, where I have just basically copied this face here, and I've created and if I just hide everything else, I've created basically an interface which I'm going to share or use downstream via the derived methodologies a little bit later on. But yeah, you can see where that's come from. Now, I'm not going to go through all of the rest of these part studios, but I've split things out into individual part studios for things that kind of have functional and topological relations, very tight relations between them. I mean, it is possible with an assembly this size to do more in one part studio than I did, but it is nice to keep things clean and separate wherever possible. I'm using, again, these global variables from the variable studio to bring in these key dimensions like the piston diameter and that sleeve diameter, the outside diameter of the sleeve there, so that I know that it will match up to the engine when bringing it back together. Right. So fast forwarding, there's a bunch of different part studios in here, and then I started putting together some sub-assemblies. So okay, now that's not the best one to look at. Maybe this is a good one to start with. This is a sub-assembly of the rear cover assembly. It's got the needle valve in it and some fuel and inlets and outlets, as well as the fasteners and the gasket. So this together constitutes one of my sub-assemblies. Now the conrod, in fact, was an example. I showed you that there was a sub-assembly because these bushings are driven in and pressed in. So they are separate. They start out life as separate parts, as from the actual cast piece of conrod. But in fact, they're not available separately. It's an inseparable component, they call it. And as a part number, it is only available as a single thing. So rather than make it a sub-assembly, what is a good idea is to model it the normal way, and you can make these different parts, but then you do a composite part. So using the composite part feature, I've kept it open so that I can keep these separate parts around, but the connecting rod composite part consists of all three, right? And that is the entity or the instance that I'm going to use in my main assembly. I'm not going to use the individual sort of sub-assembly instances or the instances in the sub-assembly. So when you have inseparable components like this, then the composite part is a really good idea for doing that. And you'll see, if we then now go to the, fast forwarding a few more part studios, and we'll get to this one in a second, you can see what is going on to create this assembly. And there's a lot going on, in fact. You'll see different icons for different things representing stuff that I'll highlight now. Now, the connecting rod, you'll see, is a single instance, and it's got the composite icon because it is a composite, right? So it's in here, you can isolate it, you can see where it is. In fact, if we look at the bill of materials as well, the connecting rod, which is here, is a single item, and it's got a single part number, right? So it doesn't have part numbers for the bushings and the big and the small end bushings. They don't have part numbers available from the manufacturer. It's just this one here. Right, so that is composites. You can see there's a bunch of standard componentry for fasteners. You can see a couple of screws there, a couple of longer socket head cap screws. Right, we have some traditional sub-assembly work going on with the carburetor. You can see that it consists of a number of things, including an O-ring. Actually, let's have a look at the whole bit. Isolate. There we go. You can see it's got an O-ring, a throttle arm. There's a nut on the end here, and then there's something. If we have a look inside it, there's a little bit going on. There's a secondary mixture control valve in here, which is controlled by this screw. Yeah, but let's stay away from that for the second. So that is just a traditional sub-assembly, which has been assigned, a mate. The mate is just a fasten mate into reference in here. Right. What other fancy thing? Oh, then there's some individual things like the crankshaft and the piston, these are individual part instances that have been assembled in to here. Here's an interesting one. This looks like a composite part, but it's got an additional thing, right? Which means it's a configured composite part. In addition, it's come from a linked place, right? So this is one of the bearings. Again, this is the rear bearing. It's a standard SKF 6902 bearing, and the front is, it's funny because they use a metric bearing on the back and an inch bearing on the front, an R6Z. The Z referring to the fact it has a seal on the front of the bearing. Let's have a look at that. That's it. There's the sealed side of the bearing, and there's the unsealed side of the bearing there. Funny, and that's an inch size one. Anyway, both of these bearings are coming from a linked document, and we could follow that link if you like. Let's have a look at that. So this is my SKF document. There's a lot of configuration going on in here. I can actually configure for the bearing designation, whether it's got both seals or no seals or one seal. And if you have a look at the designation, you get a hint to see there's a lot in this, right? So it's basically the whole catalog. I built a configurable parametric model like you can see here, and then went to the bearing catalog and copy and pasted the appropriate rows into and there's a couple of, I think there's 1,500 or something. It's a lot, but it's fun because I can use a configured link to this, the size, whether it's fully packed, whether it's sealed, and the naming is based on as well. So it's a composite part again, so it's a single part instance that needs to go into this assembly like this, and it will show up with the correct part name according to the designation that I've chosen. So there's a lot of configuration work going on in there, and you can see that for those two bearings. Blah, blah, blah. Okay. Right, what have I done here? So this is the head, all right? This is the rear cover, the muffler. Okay, moving right along. There's a couple other icons that are worthy of exclamation as well. And this one here, it means something was done in context. And the piston, what would I need to do in context for that, you ask? And I'll tell you that the shape of the piston at the skirt here needs to accommodate something that's going on inside. What did I just click on there for? All right. So if I just hide that crankcase and hide a few more things, I'm hitting the Y key because that's why would I want these instances shown. That's the way to remember it. All right, so you can see here's the back of the crank. This is the back of the cover, and with the piston in the bottom dead center orientation, which is what it's in now, I do want to have a clearance between it and the top of the crank, and it and the top of the rear cover there. So the way I did that was to do and right click on it and say edit in context. So I created the context just by having it here in the assembly. This is the context. And if I go to the piston, which is over here, you can see you can turn the context on or off. I mean, normally in a part studio you just have this and the the default planes, but here I've got the context available for me as well, and I can hide and show things. And what you can see, and I can actually change the view so that the crankcase is hidden. There it is. And actually I don't want the cylinder liner either. Right, so here we've got the piston, and what I did is I created a surface, not that one. I created an offset surface here, which was just by copying the top of the crank. Then let's do it here. Then I moved the boundary so that it gives me basically a big cutting tool, and then I did a split part to split that surface away from the piston, leaving me with, of course, with the 0.5 offset. So this 0.5 offset is going to give me a clearance of 0.5 between the piston after it's been cut and the top of the crankshaft. There you can see here, right? There it is. There's that clearance. So it's a very convenient way to do this in context modeling, and if the crankshaft should change diameter, or anything else changed in the assembly, I changed the conrod length, then I would have a notification that would ask me to update the context, and then that cut would be updated, and then everything would be good again. So let's go back to the assembly, and you can see here, yes, we've got that. Now, in fact, I'm going to hide the sleeve so that we can see where the no. That's the better way to do this would be to look at a cross-section. Right. Moving outside of the bill of materials, let's have a look at named positions. So there's really two positions that are really important for an engine like that, like this. And that is top dead center and bottom dead center. Now we're in bottom dead center right now, which is when the crank is all the way down, the pin on is all the way down, the piston's down in the cylinder. Top dead center is the other, when it's all the way up the top. And here we would be doing things like measuring this distance here, this gap, this so-called squish gap, and then there's an angle here as well, which is very important that we would want to be measuring. So, having named positions, and you can create different named positions with the crank in different positions if you wanted to, and you can see here that as I have changed the named position, the little blue dot here means that perhaps the context has changed. Do we want to update the piston? And in fact, I know that I don't need to because this is the context for that cut and for that the manipulation that we needed to do of the skirt in the piston. Right, so we are getting all the way through this. Now there's a few other places where in context has come into play, and one of them is with these screws which mount the carburetor. If I make that translucent, you can see that there's a couple of screws which mount into the carburetor body, and it's very easy to see initially where these screws would be on the clearance side of things, but I want to create a hole so that it lines up. And if I hide that, you want to make sure that this hole lines up with the outside hole. And these are different part studios, so I'm not going to just build one feature to do that. What I will do is edit this part in context, and you can see here, I can go back to the context where we created that. And that is over in the carb body part studio, and the context for it included a couple of parts. I didn't need to include all of this, but it just looked better for the moment. And what I did is you can see the features where the context was created, and the other one's highlighted in yellow here, or in orange. And I created a couple of mate connectors hide them, I show them, there they are. These mate connectors are oriented exactly where those holes in the crankcase casting, those holes are. So that once I have those mate connectors there as a reference, then I can create in the, I don't need the context to see that anymore. I can just use these two mate connectors to orient and locate my M3.5 holes, which are going to go in there. So that's a nice use of in context modeling there as well, and a nice use of the Shift Y key to replace or unhide something that was previously hidden there before. Now, there's one other an obvious in context usage, and that's for this little piece of silicone fuel pipe that connects these two. There we go. See, it connects these two fuel outlets there. So instead of editing in context, I created in context. And to create in context, it's kind of easy. Let's we don't need, for instance, the head. We don't need we do need the rear cover. We do need the carburetor, but we don't need many of these other things. All right. So we could, in fact, we don't even need the. We don't need that or 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 that. All right. If you really minimize, you could really minimize the stuff that you keep in context, that you keep around for the context. It can keep things simple, especially if you have a more complicated model. This is not a complicated model. But that's kind of the minimum context we have. All right. Oh, actually, the minimum context is this. So these two outlets are all we need to, say, create a new part studio. And I'm going to use the origin of the assembly to create that part studio. Now you can see in stippled color the where that context is, and then you can start doing some modeling. So I'm going to then say create a mate connector there, and one of the new options with mate connectors makes it very convenient for things like this is that I don't have a body right now to make to have as the owner, so I can actually turn that off and just create the mate connector straight away as is like that. Once I have that, I'm going to, this is going to be a little pipe, so you could use a 3D fit spline, or maybe you could use, some other. You could use a bridging curve. Why don't we try that? You could just, with a bridging curve, you could say make it tangent on each end, and we're going to use a mate connector on each end like that, of course in the right direction. And yeah, job done. We could then probably sketch on that mate connector some kind of hose like this. We'll get the sizes right later, but then just sweep that solid section down that path that we created for that hose, and we chose the end of that. I would then, do a move face operation there, maybe move it 5 millimeters. Oh yeah, that was kind of convenient. Actually, kind of perfect. So that creates the hose in context of those fuel outlets, and it's going to be associative to them. So if the fuel outlets change size, shape, orientation, then we just have to update this context using the update context button and have these features update there again. So this is exactly what I did in the actual part studio that I did this in. I think I used a fit spline and a sweep and a move face, right? But I had to add a couple of sketches. So just thinking off the top of my head there, it was easier and probably kind of cooler to use the bridging curve rather than 2 sketches and a fit spline. All right, whatever, you could do things many different ways, and it's all good. So back to the assembly. If we show all the instances again, you can see that that fuel hose has been created in context. You can right click on it and edit it back in its context, or update it if it needs to be changed orientation. That pretty much takes care of the modeling. Let's have a look. I was starting an explode view here before, and one of my explode steps seems to be in error. What happened? Actually, I know what happened here. This is when I changed the conrod from being 3 separate parts to being a composite part. So let's remove that. You can see down inside that the poor little conrod has been left on its lonesome. So let's put it back to where it needed to be, which is up there, and everything's happy again. That's good. So I don't like too many lines on the explode view. I've just left kind of 1 or 2 in there. It's easy to, if you pick any step, you'll see that this explode lines option is in here. So I typically turn them off and control a particular one that is going to be the one I'm interested in. And of course the explode lines are cool because that's what I'm going to put on the drawing. So my drawing consists of a bill of materials with all of the part numbers and a couple other sheets. What have we got? A general view just of the overall assembly, and maybe an exploded view here. Again, this needs to be updated because we changed the composite part. I was going to update it now, and this is now going to be reattached. Now, something that's nice is if you don't choose an edge reference, if you choose a face reference, you'll get this sort of dot area, sort of definition designation on the face, which is where where it's pointing to. I like, it's nice to use faces as the reference for that. Very clear. Yeah, so that's just the beginnings of a little book of drawings here. Now, I think we've gone on a long time. I've gone through most of the modeling approaches and maybe some tips and tricks in there. The last thing, I guess, is with Render Studio. So I'll just have a really quick look in here. One of the things that we've done in Render Studio is, one of the things is rewrite it, right? Probably 2 or 3 releases ago, you would have seen the what's new about Render Studio, how its data is now all stored in the Onshape document, meaning, and the huge benefit for that is, of course, the branching and merging, micro versions, collaboration, all of those good things that you enjoy with Onshape modeling now extends to Render Studio as well. So that's a huge thing, and it also means that there's no need for a save button. There's no need to create that scene page as before, where you had to save scenes and load them up. That's all completely obsoleted now, which is great. Right, the other thing that's changed is a lot of the user interface has changed to become a lot more Onshape, Onshape friendly. Now, it can't be exactly the same because there's a lot of different constructs in Render Studio that don't have an analogous or exact same thing in Onshape Part Studio or Assembly Studio or something else. But by and large, it's very, very familiar to Onshape sessions and modeling users. Still the same power, and actually there's a lot of new superpowers that have been given to this environment as well, especially things like projectors, creating projectors to change the texture mapping or the UV mapping is a whole lot easier and powerful now. Manipulating things, it's just a lot more accessible. When you have a look at these tabs that are down the side here, controlling the environment for custom background images, or the scene itself to control the renderer, or the appearance editor. a lot of that has been completely overhauled, and the libraries themselves as well. You can see down the bottom here, there's some libraries. Let's play with something. No, you can. In fact, this has already been pretty well set up by me before. So let's just go to a nice view, come in a little bit, and when you're starting to explore this, don't forget about the view cube. It looks the same as Onshape Part Studio and Assembly Studio and things, but there's a lot of things that are specific to rendering in here, including the stylized versus photorealistic rendering, the background controls. The background controls are where you can change the background type or turn backgrounds off completely. Importantly, you can do depth of field control here. So let's choose a point on the model like that. So we just use the crosshairs to choose the target. And if you change the F number, this is like an old style camera, if anybody remembers these things. You can see here I've got a much shallower depth of field. If I go to 2.8, you really get a narrow depth of field here, which you can use to really bring out some realism in the images. If you don't use depth of field and everything's too clear, it's so obviously fake. So I encourage everybody to play with the depth of field controls when setting things up. And you don't need a fancy background to get some nice compelling imagery just that way. Right. So yes, I have gone on a long time with this one. I have enjoyed this modeling, and you can see I'm experimenting with different materials. I've got a translucent red plastic just for no other reason than it looked kind of cool. But yeah, I've enjoyed using the new Render Studio in here. I have also enjoyed some of the new things from the version graph, the task management, I don't know, none of the new things over here, existing bill of materials and PDM type of activities. It's a pleasure to model in Onshape, and I like doing it as much as I possibly can. Of course, I do have a day job, which thankfully does let me use Onshape a lot of my day. But for projects like this, I really enjoy getting into it, and clearly enjoy talking about it as well.